Hello, so question 12. ABC and ACD are right angled triangles. D to C is 8 centimeters. ADC 45. Work out the length of AB with angle ABC being 20 degrees. So AB is here. Up here, I'm going to label it X. If I can just get my draw function working, that would be nice. Wouldn't it? Be nice to draw some things. We'll go with that colour. There we go. So that's X. Okay, interestingly, angle or triangle ADC is a special kind of triangle because angles in a triangle add up to 180. So that angle there is 45, if you can read my terrible writing. And that means that those two lengths are the same. So we've got 8 centimeters for the length of AC. Okay, we can now solve this. We're going to use trigonometry because we've got a right angled triangle. I've got the right angle in the bottom left. Opposite the given angle is length 8, and then our hypotenuse is x. So we're going to be using sin, SOH, and I like to put these into a formula triangle because it's really easy for us to use. So we're looking for the hypotenuse. If we cover that up, that means we're going to use the opposite divided by sin. So our opposite is 8, and that's going to be over sin 20, and that's going to equal x. So x will equal, and then we put that into our calculator. Please make sure that your calculator is in degrees. If you're in radians, you're going to get something totally different. Radians is something that's not used at GCSE, but it is used at A level. And our length there, 8 divided by 20, divided by sin 20, is 23.390435. We're rounding it to three significant figures. Our third significant figure is that 3, which means we're rounding it to one decimal place, and that gives us 23.4. Question 13. I don't think I've seen a vectors question like this, but I love it. So we've got 3a, that's 3 lots of 2 minus 3. Take away 2 lots of b, and that's going to equal 8 minus 17. Right, first thing I want to do is I'm going to tidy everything up here. I'm going to take away this vector, and then that's going to equal 2b. So now my 2b is positive, and when I'm dealing with things, this is going to be a lot nicer. All right, so I'm going to multiply this left vector by 3 now. So 3 times 2 is 6. 3 times minus 3 is minus 9. And then that's take away 8 and minus 17. That's equal to 2b. Let's do the calculations now. So 6 take away 8, negative 2. Minus 9 minus minus 17 is going to be minus 9, add the 17, and that gives us 8, and that's still equal to 2b. So finally divide throughout by 2, and that gives us minus 1, 4 as our final vector. I'm going to put that in my little answer line down there. Just check everything's okay. So find b as a column vector, and I've done that, so I'm happy with my answer. Okay, question 14. So factorize fully. I've noticed something about this one. There's two big key things. First thing I can do is take out 4 from both of these two terms. So 4 open bracket p squared take away 9. Now both of these numbers are square numbers inside that bracket. There is a subtract symbol between them, so it's the difference of two squares. And that means what we'll get is we'll have 4 outside of the brackets. We'll have 2 brackets that start with p. They're going to end with 3. One will be positive and one will be negative, so as to then cancel out any p's that come through. So we've got 4, p plus 3, p minus 3. Okay, part B is a show that question. We've got 3 brackets that we need to expand. Now I've always treated these quite carefully, and I will always do the 2 most difficult terms first. So 3m times 2m, 6m squared, 1 times 2m, 2m, 3m times by minus 5 is minus 15m, and then 1 times minus 5 is minus 5. We then collect those two terms. We'll collect the two terms, we'll simplify the whole thing. 6m squared, take away 13m, take away 5, because minus 15, add the 2, gives us minus 13. Now we're going to multiply that by that third bracket that I left, and it's the easier one. So effectively, the top row, all we're doing is raising the power of m by 1. And then for the next row, everything's just multiplied by 4. So 24m squared. Take away 52m, take away 20. Now, when we write out our answer, the 6m cubed is fine. Our m squareds need to be collected. So we have 11m squared. 52 and 5 make 57. And then we just put that minus 20 at the end. Question 15. So we have got two triangles and we need to prove that they are similar. So when we're doing this mathematically, we need to describe the angles using 3 letters, and the middle value will be the point where that angle is. So PQR is equal to PRS, and that's because angles in the same segment are equal. Right, the next one, and it's the same reason, is that QPR, up the ranges, equals Q. I just want to get that right. QPR, QSR. I've wrote the wrong thing for this other one. I'm really sorry if I've confused you there. That was a mistake from me. It's PQS, PRS. I was just looking at it thinking, and I'll explain why. I'll just write this now. PQSR. Is that you'll notice that the first and the second, the first and the last letters are the same for that. QR, QR, PS, PS. And that gives you the indication that they start and finish at the same place for both those two angles. So angles in the same segment are equal, angles in the same segment are equal, and then finally we've got SXR is equal to PXQ, these two angles in here, and that's because opposite angles are equal. Simple as that. Opposite angles are equal. Right, finally, because we've got 3 angles that are the same, these two are therefore similar. Job done. All right, question 16. So this is a bounds question. It wants us to work out an upper bound for the value of p. And what we've got in our formula is we've got a value being divided by another one. So to get the biggest outcome, we want the maximum at the top divided by the minimum. And then that's going to give us our upper bound, because if we had a smaller number divided by a bigger number, it's not going to give us much of an outcome. But if we've got a massive number shared out just between a few people or a few things, that's going to make the bigger number. So our maximum for E, and that's to 1 decimal place, 6.8, that's the nearest 0.1. Divide that 2, that gives us 0.05. So this one goes to 6.85. I don't know why I wrote a 6 there. Unbelievable. And then 0.05 is correct to one significant figure, and that is to the nearest 0.01, which if we halve it, that gives us 0.005, which means our smallest number, we're going to subtract it from the 0.05, get 0.45. Right, now we're going to substitute this in. So 2 lots of 6.85 divided by 0.0. No, let me get this right. Not 0.0. Sorry, I've said 0.0 too many times. 0.045 is our minimum. I'll put that up incorrectly. There we go. And then we're square rooting all of that. Now I'm confident enough to just put that all into the calculator. So shift square root fraction button 2 times 6.85, and that's divided by 0.045. 2 square root 685 over 3, which if we write it as an actual number using the SD button, we get 17.44833644. And then to 3 significant figures, we want it to 1 decimal place, so that's 17.4. Question 17. I apologise for question 16. There was clearly a pun I should have used. I was bound to forget it. Okay, so question 17, we've got a histogram. When we multiply some values, the frequency density and the class width, we get the frequency. And by putting that into a formula triangle, it's very clear that we need to divide our frequency by the class width in order to get the frequency density. So 90 divided by 1 is 90. 48 divided by 0.5 gives us 96. 22 divided by 0.5 is 44. 8 divided by 1 is just 8. And then 12 divided by 2 gives us 6. So this is going to make drawing this histogram quite tricky with the scale that we've got to use. I need to get all the way up to 96, so I'd like that to be 100. So 2, 4, 6, 8, 10, 12. So that's going to be a frequency density of 20, 40, 60, 80, and 100. Don't need to go any higher than that. And our first one is going to have that frequency density of 9, so it comes across here. And then down for the 1. Of course, you'll be using rulers, won't you? And you'll be using pencil, so that you can be nice and accurate. Our next one's up to 96, so that's going to be just 2 below there. Only goes across by 5 squares. Then we've got 44. We go across by 5 squares again, so 40, 42, 44 goes into there. I could change the colour of the pen, every one of these. I've only just thought of it, so I'm not going to change. Carry on as we are. This next one goes to 8, so that's a 10. And what's the width of it? It's a whole one, so 10, that's going to be 1 below the 10 for there. And this last one, that's got a width of 2. We go up by 3, just a bit lower. There we go, histogram drawn. So that's part A. What have we got for part B? Oh, yep, another histogram. Find an expression in terms of n for the number of Year 11 students who live between 3 and 5 miles from the school. Okay. Histogram shows information about distances in miles. That some of the Year 11's students live from school. The number of Year 11 students who live in the school is n. So what I think I'm going to do here, we've got between 1 and 2 miles. So we're going to call that n, and therefore the class width of 1 times by n gives us n. Now, n is 15 squares up, and then this one goes up by 3, so that's 3/15, and it's got that width of 2. So 3/15 of n times by 2 gives us 6/15 n, and then we can simplify that into 2/5 n.